So welcome to Shifting Grids. In the previous lesson, we have seen how quadratic curves can be plotted simply by coming up with a table of the values of x and y. Then you plot them on a Cartesian plane and you come up with a smooth curve to represent a quadratic function. In this lesson, I would like us now to check how equations can be solved using the graphical method. Therefore, to solve quadratic equations using the graphical methods, you first of all plot the curve. Then after plotting the curve, for the given equations now, which are to be solved graphically, you subtract the equations with the main function which is used to draw the curve. Then after subtracting now, you draw a suitable line of the difference you get after subtracting an equation from the quadratic function. Then where they intersect now, you take those coordinates and they will give us the values of x and y, or rather you will have solved the equations simultaneously. Let me give an outline of what I'm saying. This is what you're saying. Okay, we're saying simultaneous quadratic equations. Simultaneous quadratic equations. It is what we are solving. Therefore, we say you first of all plot the quadratic function. Of course, on a Cartesian plane. Then after plotting it now, for the equations to be solved, subtract them, the equation from the quadratic function and draw a suitable line using the equation. Using the equation you get after subtraction. Using the equation you get after subtraction. Then after that now, read the coordinates of the point of intersection. Of the curve, the quadratic function, and the line. That is what will give us the solution. We can check this one using an example. And we'll use our KCC equations here. When you're told, using the grid below, draw the graph of negative 2x squared plus x plus 8 for the values of x between negative 3 and positive 4. Then from your graph, find the roots of. Find the roots of an equation here, negative x squared plus 8 plus 8 is equals to 0. Negative x squared, negative 2x squared plus x plus 8. You find the roots. Then lastly, part C. By drawing a suitable line graph, find the roots of negative 2x squared plus 4x plus 12 equal to 0. Find the roots of negative 2x squared plus 4x plus 12 equal to 0. So that is the question. Said first of all, we draw the quadratic function. We draw it. The function is y is equal to negative 2x squared plus x plus 8. So we'll get x and y. Then we plot these two, plot the coordinates to see how the graph shall be from negative 3 up to positive. So we can get the values of y with those corresponding values of x. Therefore, negative 2 into negative 3 squared, because it is x, plus negative 3 plus 8. Therefore, we shall have this one as 9. By 2, we get negative 18 minus 3 plus 8. Therefore, negative 21 plus 8, we get negative 13. Then when x is negative 2, we shall have y as negative 2 into negative 2 squared 2 plus 8 plus minus 2, just minus 2. So this is positive 4. By negative 2, we get negative 8 minus 2 plus 8. Negative 8 plus 8 is terminated, so we get negative 2 as the answer. When x is negative 1, so we fix negative 1 in this equation, and it should become negative 2 into negative 1 minus 1 plus 8. So this becomes negative 2 into negative 1 squared. So that becomes a positive 1. So negative 2 minus 1 plus 8. This is negative 3 plus 8, positive 5. Then when x is 0, we will have this one becoming a 0, this one becoming a 0, positive 8. When x is 1, we will have negative 2 into equal 1 plus 1 plus 8. Therefore, this is negative 2 plus 1, we get negative 1, negative 1 plus 8, we get 7. When x is 2, we fix 2 here, so negative 2 into 2 squared plus 2 plus 8. This is a 10 already. Positive 4, by negative 2 we get negative 8 plus 10, we get negative 6. Positive 2, sorry. Positive 2. Positive 2. When x is 3, we shall have negative 2 into 3 squared plus 3 plus 8. And this becomes positive 9, so negative 18 plus this is 11. We get a negative 7. Then with x as 4 now, we shall have negative 2 into 4 squared plus x, which is 4 plus 8. This is 12 already, plus negative 32. negative 32 plus 12, we get negative 20. So this is the curve we'll be plotting. This is the curve we'll be plotting. So we can come up with the curve now. Because the coordinates of y are very large, so we are going up to negative 20. Then we can use intervals of 2. You can use intervals of 2. Can use 2 units for the y-axis. And the y-axis, we have the highest positive value as 8. Therefore, we still need values upwards. So x, for the x, we can use intervals of 1, but for the y, we use intervals of 4, intervals of 2, like that. So that's our y-axis. The coordinates are negative 3, 13. So negative 3, 13, negative 3, 13 is here. The other one is negative 2, negative 2, negative 2, negative 2, which is here. The other coordinate is negative 1 and positive 5, negative 1, positive 5. It's in between 6 and 0, 8, 0, positive 8. It is on top there. The other one is 1, 7, 1, 7. The other one is 2, 2, 2, positive 2. The other 3, negative 7, 3, negative 7, which is here. Then we will have 4, negative 20. 4, negative 20, which is here. Therefore, we can draw the curve. That is the desired curve. That is the desired curve. Curve y is equal to negative 2x squared plus x plus 8. That is the desired curve. Then in the next question, we are told to find the roots of negative x squared plus x plus x equals to 0. Therefore, I said you subtract the equation from the main, from this function. We are finding the root of the equation when we subtract this, just getting y is equals to, this side becomes a 0. Therefore, line y is equals to 0 is just the x-axis. Y is equals to 0 is just the x-axis. Therefore, the roots of this equation will be x is equal to where the curve cuts the x-axis. Where the curve cuts the x-axis, and this is 1. This is 1, therefore this is 1.8. This is 2, therefore 2 point. So negative 1.8 on x is equals to 2.2, positive 2.2. Then lastly, part C of the question, find the roots of. So we take the original equation, negative 2x squared plus x plus 8. Then we are subtracting the equation now. 0 is equals to negative 2x squared plus 4x plus 12, like that. So y will be equal to, when we subtract this one in Asia, so x minus 4x, we get negative 3x, minus 8 minus 12, we get negative 4. Therefore, we are drawing the graph of the line y is equals to negative 3x minus 4. Therefore, for this one, we also get table. We can use the x and the y intercepts. When x is 0, y is going to be negative 4. And when y itself is 0, no? So we can go to when x is something like 4. When x is 4, what shall be y? So y is equals to when x is 1, we have gone too much. When x is 1, y is going to be negative 3 minus 7 minus 4, negative 7. Therefore, 0, negative 4, 0, negative 4, then 1, negative 7, 1, negative 7 here. So we come up with this line now. This is the line we need. Connect these 2 points. So the suitable line is this one. That's the line we want. The line is line y is equals to negative 3x plus 4. Therefore, now to get the roots now, part C, to get the roots, the answer for part C, the curve and the line are intersecting. They are intersecting at point. At this part, it's x is equal to negative 1 point. X will be negative 1.7, and x is equals to, on this other side, they're intersecting at point x is equals to 3.5. So 3.5 and negative 1.7 are the points of x where the line and the curve intersect. Where the line and the curve intersect. Now, when told to solve simultaneously, you'll be plotting the curve and the line on the same axis. Then after plotting them, what you extract is where they are intersecting. You pick it as a coordinate. Then after picking it as a coordinate now, you say now that is the solution. For example, if we were solving y is equals to negative 3x minus 4, and the equation y is equals to negative 2x squared plus x plus 8 simultaneously. We could have plotted them that way. Then we read the coordinates of the points of intersection. Where is the points? Like this one, it's 3.5 and 14.2. Therefore, we say when x is 3.5, y is 14.2. Same wise to the other coordinate of intersection. Therefore, that's how we solve equations using the graphical methods when they are quadratic. So thank you very much for following us. We can meet for something else later. Thank you.